Now, another exciting application of logarithms would be the earthquake and how the Richter scale is measured. Living in California, I'm sure you're concerned about this. It's kind of common, or more common for us. So it's kind of interesting whenever you hear, oh, there's an earthquake of 3.5 magnitude, or what's that in comparison to an earthquake of 5.8 magnitude? We kind of realize that the numbers don't seem so far apart relatively, but you're quite a few amount more intense if you're a 5.8 earthquake versus a 3.2. So to explain this a little bit more, we'll notice that the way the Richter scale is set up, it's in terms of logarithms. So when we talk about Richter scale readings, you'll notice that we have the common logarithm. And remember that common logarithm has base 10. So R is considered the Richter scale reading, named after the person who came up with the whole idea. We have the I standing for the intensity of the earthquake at hand. And then I sub 0 is a reference intensity constant. So we're not going to go into figuring out what the reference intensity constant is. You'll notice that it doesn't matter in these types of examples. But it's really more interesting to me to just try to understand when we're looking at an example like asking, how many times more intense is an earthquake that measures 6.2 on the Richter scale than an earthquake that measures 5.1 on the Richter scale? So you'll kind of say, well, they don't look that far apart. Is it really a big deal? So we double check. So basically, I kind of look at this concept. If there's two different earthquakes, you basically have two different setups. When dealing with the Richter scale. So if we're looking at the one with the 6.2 reading, I'm going to utilize my formula. So if I'm talking about 6.2 reading, that's telling us that R is 6.2. So I have 6.2 equals log of I. That's the intensity of the earthquake. And because there's two different earthquakes, I'll set it with a maybe a subscript of the 6.2. You can say like I sub 1 or anything else, but you don't want it to be confused with the other earthquake. So that's how I'm just kind of understanding this. And that's over the reference intensity constant, I sub 0. Now taking a look at the 5.1 reading, it's kind of the same idea. It's another version of the R. So we have 5.1 equals log base 10. We have the intensity of this particular earthquake, so that would be I of maybe 5.1 over the reference intensity constant. So there's a couple of ways to play with this, but we kind of have to understand what they're really asking. So when I'm reading this, it's saying how many times more intense is an earthquake that measures 6.2 on the Richter scale than an earthquake that measures 5.1. The idea is that they're going to want us to compare the intensities. And what they mean by comparing the intensities, we're looking at, I sub 6.2 versus I sub 5.1. And a lot of times when we like to compare two numbers in mathematics, usually we write them as a ratio or a fraction. And so if we kind of know already, just by experience, that a 6.2 is stronger than a 5.1, when they talk about how many times more intense, we basically want to understand that what is the ratio of the 6.2 earthquake intensity to the intensity of the 5.1 earthquake. So we basically want to come up with the results of this. Now, I'm going to take this off to the side. Before we can jump into this, what we want to do for ourselves is play around with solving for the intensity of each of the earthquakes. So there's a couple of ways to do this, but I kind of say, well, if you're trying to solve for the intensity of each of the earthquakes, you have to get them out of the log argument. And what we have in both of these situations, if you didn't notice, the log is on one side of the equation only. So technically, you've got yourself a type 1 log equation in both cases. So with these types of problems, it's really, really more convenient if we want to rewrite it in exponential form. And we do that by just understanding what's the base of the log if we don't see it. So the common logarithm has base 10. So we're going to rewrite it so that we're saying 10 taken to the 6.2 power is equal to the argument of the log. So the intensity of the 6.2 earthquake over the reference intensity constant. So we got the log out of the situation. And we really want the intensity of the 6.2 earthquake to be isolated itself. So what we're really more concerned about is, well, how do we get the I sub 0 out of the way? We just take the I sub 0, multiply by I sub 0 on both sides. Because we know it's a constant, that's not 0. And we'll end up having I sub 6.2, the intensity of the 6.2 earthquake is the reference intensity constant times 10 to the power of 6.2. So I can take that and I can replace it in the numerator. So I'll do that when I'm comparing the intensities. So it's I sub 0 multiplied by 10 to the 6.2 powers. Pretty huge number there. So same story for the 5.1 equation. We are still going to rewrite it in exponential form. So we notice we still have base of 10. We take it to the other side. So that is 10 to the 5.1 power equals the argument. That's I, intensity of the 5.1 earthquake over the reference intensity constant. Now, keeping in mind, we're still trying to solve for the intensity of the 5.1 earthquake. Same story, multiply both sides by the reference intensity constant. And what that leaves us with, I sub 0 times 10 to the 5.1 equals the intensity of the 5.1 earthquake. So now, if we're writing the comparison, we go back with our ratio. And I sub 5.1 is I sub 0 times 10 to the 5.1. So this is what I was talking about, how the reference intensity constant really doesn't matter at this point. Notice that if you have the same number over the same number, they end up dividing out. So you're going to have a comparison, 10 to the 6.2 over 10 to the 5.1. And you'll notice that you're talking about numbers. You could plug this into your calculator right away, but you also notice that you're dividing with the same base. So you can use the exponent laws to help you out a little bit. So 10 to the 6.2 over 10 to the 5.1 is really 10 to the 6.2 minus 5.1. So then you'll notice you could play around with your calculator if you'd like. And you could say, okay, well, what is 6.2 minus 5.1? I mean, or you could do it by hand. It's up to you. So 6.2 minus 5.1, we're getting it's 10 to the 1.1. So it looks like the difference between a 6.2 earthquake and a 5.1 earthquake, it looks like it's about 10 to the 1.1 times stronger. Well, what does that really mean? I mean, it doesn't look that crazy, but Let's check it out. 10 to the 1.1 on our TI. We have about 12.5 or 12.6 times more intense. So I'm gonna write that back. So it's about 12.6 times more intense. And that makes a lot of sense. When you're looking at the Richter scale reading, just to kind of go back, remember the Richter scale reading is in base 10. So if you're talking about the numbers, how far apart they are, if you go to, and I'm just going to take this in terms of just integers. So if you go from 5 to 6 to 7, the difference are the intensity going from a 5 Richter scale reading to a 6 Richter scale reading is about 10 times. Going from a 6 to a 7, it's about 10 times. So they're 10 times stronger than each other when you're going up from each scale. But when you go up 2, really what's happening is you're looking at base 10. So if you actually go from a 5 to a 7, that is 100 times more stronger than a 5.0. You want to go crazier, and hopefully we don't see this anytime soon, but you want to talk about the 8 Richter scale reading versus a 7 Richter scale reading. It's 10 times stronger than a 7 Richter scale reading. If we actually look at this, if we're comparing this to a 5, going from a 5 to an 8, that's 1,000 times stronger than a 5.0 if you're looking at 8 versus a 5. So I don't know if any of you have been through any of some earthquakes, but definitely a 5 is pretty scary in itself. And if you're looking at something being 1,000 times stronger or even 10 times stronger, that's pretty intense. But it's really cool that we can use mathematics to explain this as well. So one of my favorite applications. Hope this helps you out and hopes you gives you maybe a better perspective of understanding the mathematics around us in our world. I'll see you in the next chapter.